All right. Good morning, everybody here. Thank you all for coming. Also to the people at the other side of the street. I don't know where the camera is, probably over there. Good morning. Thank you for coming. I'm going to do a short presentation about the development of a motion-based simulator for fast boats. We brought a prototype unit, or a demo unit as you wish, and it's out there at the other side of the road. And you can go there for a test drive later today if you are interested. I'll try to leave some room at the end of the presentation for some questions and hopefully answers as well. My name is Maarten van Donselaar. I'm the founder and CEO of the company called CRUDEN. And just very shortly on the company, it was founded in 2003, based in Amsterdam, Netherlands. We are currently about 30 employees. We have a very much an automotive background, so we do the simulators you might see that are being used in Formula One and mostly in the automotive industry for development purposes. And we also have a large client base in the academic world, so really into the research. Currently, we have, I lost count, but around 110, 150 simulators installed worldwide. Yeah, about simulators. Roughly, you could say simulators are being used for two main purposes. The one side is a research simulator, and what we are talking about today is not a research simulator. Research simulators are being used to develop a new car, a new boat, a new airplane, a new helicopter, a new submarine. So the focus is really on the technology that's being developed. Today we're talking about training simulators. So training simulators are there to be used to train the people. And training simulators are well established in motorsports, a very popular item in television show also these days. If you go and watch the pre-show for a Grand Prix, you very often see the drivers in their simulators. Well, big chances that you see our equipment over there. It's also well known for flight simulation, so training the pilots, both in civil as well as military aircrafts. And closer to our world today, the big type bridge simulators that are being used to train people who go out on the sea in the big ships, which are typically static simulators. So these simulators are they're huge. The complete bridge is there modeled. You have an out-of-the-window view, mostly at least 180 degrees, but sometimes also even behind you. But the bridge does not move. It's a static simulator, and still these beasts can make you quite seasick, no problem. So on a training simulator, typically if we look to a fast craft simulator, what I'm talking about today, two things can be trained. So the one thing, and that's what is also most appealing to if you bring a unit as a demo to a show like this, is the handling of the craft. So you jump in the seat and you hit the throttles and you're driving a boat, and it actually also sort of feels like you're driving a boat. So that means you can train the people how to use the craft, how to operate it, how to read the sea. That's the one part, but maybe even more important is that you can train a group of people how to work together. So a crew on a boat, helmsman, navigator, how to communicate, or two boats who are platooning or communicate with the mission control. And if you keep on practicing that on a simulator, the first time you go out in real life, many of the tasks are automated, and that's the main reason why simulation is being used. That it's people love to ask, Maarten, how realistic is the simulator? And we also say, it's not really realistic. It's not like it doesn't even come close to driving a real boat, but it's just good enough to have a proper training value. So if you want to use a simulator for training, what do you need? Well, very important, realistic controls. So if we look up to the the first picture over there, you see we use all the original equipment that's being used on the real boat. So we replicate the console as it's being used in the real boat. We need proper dynamics. I will talk a little bit more about that later. Dynamics means it's a simulation model. It's not a movie and a replay. People tend to ask, oh, where did you get that movie from? It's not a movie. It's we're using state-of-the-art graphics. Graphics means, well, people know it from video games. So it's all animated out of the window views, what we're seeing. And last but not least, you need to get relevant feedback from a simulator. So not only visually, but also through your controls. So if you get a kickback on the steering, the throttles need to feel realistically. If you put it in gear, you want to feel the cloink. If you get propellers, that gives you the feeling that, hey, I'm really on a boat. A little bit more about the feedback. Another interesting observation is we have the luxury to be able to have some friends in the industry where we can go out on boats as much as we want. We instrument those boats, we're taking measurements. So not only are we taking measurements from like accelerations or yaw rates, but also we monitor the inputs. So we have a very good idea of what's the response of the boat on, for instance, a step steer input. Real life data shows, we know, most of us know that, and also there are going to be some courses about it around here, I believe, Carl. It's not a very rough ride when you record 60 meter per second square of vertical accelerations. That's, well, I have here a short example of sampled data. Every couple of seconds, the boat, not necessarily the people on the boat, experience 60 meters per second square vertical acceleration. How does the simulator perform? Well, the simulator, at the max, it produces 18 meter per second square, which is not even close to what we experience in real life. Is that bad? No, it's not bad. It's good, because we do not necessarily want to hurt the people in the simulator. We just want to give them the feedback that they have the idea what they're doing and what is the response of the vessel. And for that, this is perfectly fine. I will skip the rest of those things. Another interesting thing to realize about the visuals we're using. So we're using multi-channel visuals. So there's a straight ahead view, there's a left view, there's a right view, and you can combine all those channels for a full wraparound screen or even a sphere if you want to watch the stars. And the simulator that we brought here has 3 monitors. We could say that's a budget solution. The budget solution works fine if you got a single person driving the simulator. So this is a little picture about one person driving the simulator, looking at the lighthouse straight ahead, and the lighthouse is indeed straight ahead for this guy. But if you're with 2 persons, so the helmsman has the simulator, has the lighthouse in front of him, and he's pointing at the lighthouse, but the navigator, if he looks straight ahead, he sees nothing. The lighthouse is on the port side, and he feels like he's crabbing over the sea. So we need to address that, and we could do that by, well, bigger is better. We're a projector-based imaging system where theoretically and also in practice it works fine if you get a radius of a projection screen of 4 meters or more, and then 2 people with a relevant distance from each other, they will experience something that is infinitely far away, straight ahead, as straight ahead for both people. There is, by the way, a solution for this. We could use shutter glasses, like we know from 3D movies, so we can do left person, right person, left person, right person, but I'm not a big fan of that solution. About the simulation model. In a very quick, what we're currently simulating is a V-hull button. What we do is we split up the boat between a left side and a right side. From those 2 boat halves, we calculate every millisecond the wetted length of the boat, so which part of the hull is in the water, which part of the boat is out of the water, because we have to look at those 2 parts in a different way. We're looking at chines, so the boat has hard chines Are the chines in the water, or is it just the bottom part of the hull that's in the water? And then we do the math on the water displacements, the hydrodynamics, slamming forces. We create a wake, so for the draft. We look at aerodynamics, very important when you're going fast, not only for the draft, but also it could generate a lot of lift. We handle collisions, which is nice if you touch the jetty, but also if you want to simulate a docking operation, then it's important that you could simulate collisions. We do water mass simulation, which means that if you get hit by a wave, and if it's not a rolling wave, but if it's a moving mass, that it actually sets aside your boat. For instance, if you want to simulate correctly a broaching kind of situation. Last but not least, there is a spray calculated in the dynamic model. So what does the dynamic model look like? I will not go in full detail and show you all kind of algebraic formulas, but it's interesting to see what's going on here. So on the left-hand side, we have the signals coming in from the driver, from the hardware, the controls, and on the right-hand side, we send the signals out to, for instance, the graphics and the motion base. And in between, we calculate the wetted length, which is key in the whole simulation, the hydrodynamics, the drag, the buoyancy, so the hydrostatic simulations, propulsion system, engines, propellers, water jets, whatever, rudder, if there is any, where a drive could act as a rudder as well, and the water mass wave simulation. And if we go in a little bit more detail and look in the hydrodynamics of the simulation, keep in mind this is calculated every millisecond. So every 1,000 times a second we do a new calculation of the current state of the dynamic system. And here you see that the lift is divided, of the lift calculation is divided in a left side and a right side, port side, starboard side, and it's been summed up in the end, and the forces act on the body as a whole. If we take a closer look into the port side of the simulation, here, and I can continue going deeper and deeper into the hierarchy of this simulation, but I just want to show you this part so that you get an idea of all the math that is behind the simulation. Basically, what's being done here in the top part and here is first it's determined, do we have partly wetted chines or are the chines completely dry? Those results are being evaluated in the end, where there's a relatively simple hydrodynamics calculation that results the forces that act on the hull. Here under there is another piece of math that calculates the center of pressure, because every millisecond we recalculate where is the total forces and moments acting on the hull, so we get the right response in pitching and rolling. Yeah, I think that's about it. If you want to know more about this, please ask or come to our booth later. But I think for today that's enough math. There's also, of course, still things to be done, and I want to share that with you. And also, maybe if you have driven this simulator, we're very interested in getting feedback out of you. At the moment, the V-hull button, we're cheating a bit because it has a constant dead rise over the length of the hull. So, well, typically the boat has a higher dead rise in the front, and then it goes flatter to the rear. Currently, I'll be honest with you, we have a constant dead rise over the length of the boat. We cannot do multi-hull simulations at the moment, but we will in the future. I explained we do the math every millisecond on the dynamic side, but we currently evaluate the sea surface only 60 times per second, where we would like to decouple the graphics, the visualization C from the math C, so that we can update the C every millisecond. We do radar simulation, maybe a bit out of scope, but we want to enhance that so we get a more realistic radar picture. We're working on an more advanced scenario manager, so you can define your scenario. I have 2 boats here, 1 boat there, that guy is doing that, that guy is making a mistake. We want to improve the broaching and capsize effects of the boat. And of course we're going to add more boat models. So if you're a boat builder, come and talk to us if you're interested in us modeling your boat in our simulator. It's good for you. We can generate more business together. I think if I look at the clock, it's time for some